Hello everybody, welcome back to Anantha Lakshmi Academy. Today we are going to discuss trigonometric ratios of specific angles. Already we have covered the introduction for trigonometric ratios and the corresponding exercise problems in part 2, which has been uploaded 3 days back. So today we are going to discuss the same ratios of specific angles. What are the specific angles? For few of the angles we are going to figure out these ratios. We know that the trigonometric ratios are nothing but sine, cos, tan, cosecant, secant and cot, right? For those values, ratios, we are going to figure out the specific angles like 0 degrees, 30 degrees, 45 degrees, 60 degrees and 90 degrees in our syllabus. Okay, so let's get started first. First of all, we'll try to figure out the ratios of 0 degrees first. All right, let's get started. So when we are discussing about trigonometric ratios, we know that we have all considered a right angle triangle like this, and assume that there is an angle which is theta, and all the ratios were written corresponding to this angle theta. Now we are going to figure out what happens when this theta becomes 0 degrees or 30 degrees, 45, 60, 90 degrees, etc. Alright, so let us assume this triangle, this theta as, say for suppose around 60 degrees. Then this is the triangle which we might get. What happens when this is going to be 30 degrees? This is going to go like this. What is the change that we are going to observe? If you observe, the length of the opposite side corresponding to this angle is reduced. Earlier it was B to C. If I name it as C dash, this is going to be B to C dash itself. That means it is reduced by some amount. If I am about to reduce this angle by even more, say for suppose I am making it as 25 degrees, this is going to reduce the length even more. 10 degrees. See, the point is here. Let me name it as B dash. And now what happens when it is 0 degrees? What happens here is the point C directly comes and falls on BC such that when theta is equal to 0, BC is equal to 0. I repeat, when we are decreasing the angle, the distance between B and C completely decreases and comes to a point where C lies on the point B, which indicates that BC is equal to 0. What happens to AC? Now C is on B. So AB is nothing but AC. Alright? So here if you observe, since C is here on B, AB becomes AC itself. Alright? So what is sine theta now? Sine 0 is nothing but opposite BC by hypotenuse AC. What is BC? 0. AC is AB or AC, anything. But 0 by anything is 0. Hence, sine 0 is 0. So let me figure out cos 0 the same way. Cos 0 is adjacent by hypotenuse. AB by AC. But we get to know that AB equal to AC. Since AB by AB. Why? Because AB is equal to AC. That's what happened when sine got decreased to 0 degrees. Alright. So AB gets cancelled. Cos 0 is 1. What happens to tan? Tan 0 degrees. You can figure it out directly from the diagram like opposite by adjacent or sine by cos. Either way is fine. I am figuring out like opposite by adjacent. Opposite is nothing but BC. By adjacent is nothing but AB. But when theta has become 0, BC is also 0. Hence 0 by AB is nothing but 0. Alright, now you get to know sine, cos, tan values. Can we get the remaining ratios? Yes, which are the multiplicative inverses of the same thing. So cosecant 0 is nothing but 1 by sine 0, 1 by 0 which is undefined. Alright, anything by 0 is not defined. Next, secant 0 is nothing but 1 by cos 0, which is nothing but 1 by 1, and this is 1. Cot 0 is nothing but 1 by tan 0, this is 1 by 0. This is also undefined. Alright, now let us do the same thing when theta becomes 90 degrees. Alright, theta is 90 here. See here, whatever the value of theta, I am just giving you for reference. I am just boxing it. Okay, now consider the same right angle triangle A, B, C, and this is our theta. So what happens? Let us assume the same case here. Let us assume the theta is 60 degrees here. What are we dealing with? We are just dealing with acute angles. So if you look here, this is a right angle. Anything that falls below this is nothing but acute angles. So any value before 90 degrees will be inclined in this way. But when it is going to, say for suppose there is 30, 45, 60, 90, that is how it goes. So if we can assume any value for this theta, this should be compulsorily less than 90 degrees. So let us assume this as 60 degrees. Now, if I am to increase this theta by 10 degrees, say for suppose 70 degrees, how will it go? It goes like this. Alright? Such that, and it touches the ground like this. What happens now? Let me name this point as B dash. What is happening? Earlier, when theta has become 0, the distance BC was decreasing. Now here, when theta is getting close to 90 degrees, what is decreasing? The adjacent side AB is decreasing. Alright, now what happens when this goes like 80 degrees? B comes even more closer to A. What happens when this goes like 90 degrees? B comes and sits next to, not next to, B comes and sits on A itself, such that AB is equal to 0. Alright, so now what is happening, as the theta is increasing gradually, the distance AB is decreasing in such a way that the distance AB has become 0 when theta has become 90 degrees. Alright, so what happens to AC then? Since this guy AB has come here, AC is nothing but BC. Alright, because A and B are at the same point. So now AC is equal to BC. So can we figure out the trigonometric ratios now? Yes, let's do that. So what happens here? Sine 90 degrees is nothing but opposite by hypotenuse. BC by AC. What is BC? BC and AC are equal, right? BC by AC is nothing but BC by BC, and hence it becomes 1. Sine 90 degrees is 1. Next, cos 90 degrees is adjacent by hypotenuse, AB by AC. 0 by AC, which is nothing but 0. Tan, here for tan 0, I have figured out the sideways. Right now, let me take it as sine by cos. What happens? 1 by 0, which is nothing but undefined. Can we get the value of cosecant 90? Yes, which is 1 by sine 90. 1 by 1 is nothing but 1. Secant 90 degrees is nothing but 1 by cos 90, which is 1 by 0, undefined. And the last one, cot 90, is nothing but 1 by tan 90. One by tan 90 is nothing but cos. So this is nothing but 0 by 1, and this becomes 0. Alright. So let's discuss when theta is equal to 45 degrees. What happens when theta is equal to 45 degrees? We are already considering right angle triangle, right? What is this? Right angle triangle A, B, C. This is already 90 degrees. Now this becomes 45 degrees. What happens to the other one? It also becomes 45 degrees. Alright. So this is nothing but right angled isosceles triangle. Okay. Which means this is a right, since this is a right angle. So how this angle has become 45 degrees? We know that all the three angles in a triangle is nothing but sum of these three angles is 180 degrees. One is 90 degrees and the other is 145 degrees. So 90 plus 45, 135. 180 minus 135 is nothing but 45. So hence angle C is 45 degrees. So let me assume this side as A and this side as A. So as per Pythagoras theorem, can I define AC now? AC is nothing but under root of AB square plus BC square, which is nothing but A square plus A square root 2A square root 2A. So can we define the angles now? Trigonometric ratios. Sine 45. What is sine 45? This has become root 2A. BC by AC. Nothing but A by root 2A. 1 by root 2. Alright. Cos 45 degrees next is nothing but AB by AC. A by root 2A. That is also nothing but 1 by root 2. Now coming to tan 45 degrees. What happens? 1 by root 2 by 1 by root 2. Root 2 gets cancelled. This becomes 1. Can we get the other multiplicative inverses ratios? Yes. So cosecant 45 degrees is equal to 1 by sine 45 degrees, which is 1 by root 2, and this goes up root 2. Secant 45 degrees is nothing but 1 by cos 45, which is nothing but root 2. And this goes up. Cot 45 degrees is equal to 1 by tan 45 degrees, which is 1 by 1 is nothing but 1. Alright. So how many angles did we define? 0 degrees, 90 degrees, 45 degrees. Alright. So what are we left with? 30 degrees and 60 degrees. Okay, we can draw them from a single triangle. Let's see how can we do that. All right. In the meanwhile, let me make a table for this so that you guys can remember it, because once I rub the board, these values won't be visible. All right. So let me make a table out of this. So far, since this board is not sufficient, I have prepared a table with whatever the values we have figured out for 0 degrees, 45 degrees and 90 degrees. Now we are to figure out the ratios for the angles 30 degrees and 60 degrees. Okay, first let's go with 60 degrees. So that will take us to 30 degrees as well. So let's see that how. Since this is 60 degrees, let us consider an equilateral triangle. What is an equilateral triangle? In which all the sides and the angles are equal. Okay. So for a triangle to be equilateral, what should be the angle then? All the three angles should be same, right? That is 180 degrees by 3, which is nothing but 60 degrees. Alright. So let us consider a triangle in which all the three angles are 60 degrees. This is 60 and this is also 60, and I am assuming the side to be of length 2a, 2 and small a. Okay, A, B, C. Alright, now let me draw a perpendicular from C to AB such that this line is going to make a right angle for triangle ADC and CDB. Are you getting it? So I considered an equilateral triangle in which all the three angles are 60 degrees and each side is 2a. Now, I draw a perpendicular from C to AB such that it makes right angles to AB. Alright? Now, this becomes, this perpendicular line splits AB into half. Now, AD is equal to DB such that what happens now? AD becomes A and DB becomes A. So, this perpendicular divides AB into two equal halves such that 2A becomes AD is A and DB is A. Alright. Now, 2A, what happens to this angle? This is divided into 2 now. Earlier it was 60 degrees. So, this becomes 30 degrees in angle, in triangle CDB and 30 degrees in triangle CDA. Okay, we draw a perpendicular such that it splits AB into two halves and angle C into two halves. So now if you consider this triangle 90 degrees, 60 degrees plus 30 degrees becomes 180 and this triangle 90 degrees, 60 degrees, 30 degrees. Alright, that becomes 180 degrees. If we forget this perpendicular, what happens? This angle is 60, 60, 60. Whole triangle ABC is also 180 degrees. Alright, so now that we know A, 2A, and this side we don't know. I mean the length of the perpendicular we don't know. DB we know and BC also we know. So if I am to figure out sine 60, what is it? CD by AC, right? But I don't know CD. How do we figure out? We have the Pythagoras theorem, right? So as per Pythagoras theorem, CD square is equal to AC square minus AD square. What is AC square? 2A whole square minus AD is nothing but A square, which is nothing but 4A square minus A square, 3A square, CD square. CD is nothing but root 3A square, which is nothing but root 3A. Alright, now I get to know this side. Root 3a. Can I figure out sine 60 now? This by this. Quickly, let's do this. So sine 60 is nothing but, try to figure out by yourselves, which is nothing but CD by AC, which is CD by AC. CD is root 3a by AC is 2a. This becomes root 3 by 2. Next, cos 60 degrees is nothing but AD by AC, which is A by 2A. It is nothing but 1 by 2. Next, tan 60 degrees. Sine by cos root 3 by 2 by 1 by 2. This gets cancelled and the value is root 3. Now, cosecant 60 degrees is equal to 1 by sine 60, 2 by root 3. I am directly writing off the values. Secant 60 degrees is nothing but 1 by cos. 1 by 2 is nothing but 2. And cot 60 degrees is nothing but 1 by tan 60 degrees, which is 1 by 3. Now, I told you, if we are trying to figure out 60 degrees, we can also figure out 30 degrees. Let's see how. I told you that this perpendicular has split the angle C into two equal halves, which is 30 degrees. Suppose, if I am to look from C, assuming this as the theta, can I get sine 30 degrees? Yes. Now here, theta is 30 degrees. If I am looking from here, from this perspective, what happens? Sine 30 is nothing but angle, the side opposite to 30 degrees by the hypotenuse. What is the side opposite to 30 degrees? AD by AC. So let's write it down. Here we have solved for theta is equal to 60 degrees. Now we are solving for theta is equal to 30 degrees. So sine 30, from here we are looking at it. So sine 30 is nothing but the opposite side, which is AD by hypotenuse AC. a by 2a, which is nothing but 1 by 2. Alright, cos 30 adjacent by hypotenuse, which is nothing but CD by AC. CD is nothing but root 3a by 2a. Now this becomes root 3 by 2. Alright, let's figure out tan 30 degrees. It's nothing but sine by cos 1 by 2 by root 3 by 2. The denominator gets cancelled and this becomes 1 by root 3. Now the multiplicative inverse ratios cosecant 30 degrees is equal to 1 by 2, which is nothing but 2. Secant 30 degrees 1 by root 3 by 2, which is 2 by root 3. And the last one is cot 30 degrees, which is 1 by root 3, which is root 3. So can we add these values to our table? Let's do that. What is sine 30? 1 by 2. Cos 30, root 3 by 2. Tan 30, 1 by root 3. Cosecant 30, 2 by root 3. And cot 30 is root 3. 60 degrees. Sine 60 is root 3 by 2. Cos 60 is 1 by 2. Tan 60 is root 3. Next, this becomes 2 by root 3. And the other is 2, 1 by root 3. So there we are. We have figured out the trigonometric ratios for specific angles 0 degrees, 30 degrees, 45 degrees, 60 degrees and 90 degrees. We end up writing a table, building a table which is same as in your textbook, except that instead of writing in undefined, I just wrote it as infinite. Okay, this is a symbol of infinite. Wherever you find this symbol, the sleeping 8, if you can assume it as. Alright, the sleeping 8 is nothing but our undefined, which is familiarly known as infinity. So that's all for this video. We have covered the trigonometric ratios of specific angles. If you feel the content is worthy enough, please do like, share and subscribe to Anantha Lakshmi Academy. Thank you.